Okay, what's up guys and welcome back to another video. This is Sukesh Education and today we're going to be looking at Vector Geo 2. So, it's not hard, but it's not simple too. Let's get into it. This is the quote of the day and it goes, you just have to have the right guidance to lead you in the direction until you can do it yourself. This hits me hard on a personal level and I'm sure it does to you too because we all have different perspectives on life and it affects us differently. Anywho, it's not English now. Let's get into solving some questions. Okay, so question 1a tends to be rather simple. First, let's convert this into its component form because it's in the, what form is this again? Vector form, exactly. Let's convert it into our component form. So then that's going to be, remember some basics. Remember I is equal to 1, 0 and j is equal to 0, 1. All this means is that if you see I, put the 1 on the top, and if you see j, put the 1 on the bottom. Okay? So first one, this in component form would just be 1 and minus 3 times, so dot product with 2, 4. This is what they want us to do. They want a dot product 2 vectors. And we know that the dot product for 2 vectors is a scalar. So that's a property that you must know. So when you multiply 2 vectors, when you dot product 2 vectors, you end up with the scalar, which is one single number. So what we do is we multiply the top first, and then we add it with the y component, the bottom. So basically just going to multiply 1 times 2, 1 into 2, plus minus 3 into 4. And what's that equal to? 1 into 2 is 2. And this is minus 12. So that's just equal to minus 10. Okay. That's our answer for the first one. A second one is similar. So let's break it into component form. So that's just going to be 3, 2 into this in component form is 4 and negative 3. And when you dot product it, it'll be 12 plus, and this is minus 6. And that's just equal to 6. What's this? This is just saying when it's I, remember it's 1, 0. This is just saying it's 1, 1. You know? 1 minus 0 dotted with 0, 1. Okay, wait. Let's do this again systematically. Ij. What's I? I is the top component, right? So it's 1. What's j? J is just saying 0, 1. So 1 minus 1. I'm not sure about this one. Let me see if I get it right. 1, 1. That's 1 plus minus 1, which is equal to 0. Okay, well, that works out. Because I was confused whether it was going to be a 1 or a 0. But yeah, that makes more sense. Because remember how I is 1, 0 and j is 0, 1. So that's just equal to 1, 1 then. But then because it's a negative here, we have that negative sign there. Okay. So our next question is similar. Don't get scared because it has these, surds and all that. That's just going to be root 3, I keep doing that by mistake. Component form into 2 root 2 minus 3 root 3. That's the component form, and then we just multiply. So root 3 into 2 root 2 plus minus 3 root 3 into root 2. Okay. Punch that into the calculator and you should get root 6. Negative root 6, keep in mind. Do I have my calculator here? Yes. Good. So the next one is asking for the same dot products. So let's go ahead and do it. For 1, dot product with minus 2, 3. That's just equal to minus 8 plus 3. So now you can just move on to doing it all in one step because it's really not that hard. Minus 1, minus 2 dotted with 1, minus 1. So remember, minus 1 plus this is 2, which is just equal to 1. And, okay, students often tend to get confused when it's, a fraction. Because, they're like, wait. So far, it was like this, but then now we have fractions and now it looks bigger and now it looks scary, Just take it, do like this. Remember, all you're doing for dot products are you're multiplying the x components and then you're adding it with the multiplied y component. So 2 over 3 into 4 on 7 plus 4 on 5 into 3 on 2. Okay? And then add those two together, punch it into your calculator, and you get 166 on 105. Easy. Now the next one is find this. Same thing. Multiply it with the x components and then the y components. That's dot product. So plus root 2 root 3 and multiply that. Add it. You should get root 6 plus 9 root 3. Okay. I'm only skipping these calculator works because this is calculator work. But then I just want to run through the main concepts with you guys. The next one, similar question. Multiply the x components, then the y. So that's minus 6 plus 5, which is minus 1. Same thing here. X components multiplied, minus 2. Multiply the y components. What's that? 0. Nice. Let's move on to the next page now. Looks like we're having the same types of questions on repeat. Let's use a different color. Let's use purple. Why not? So minus 2 into 2 root 6 plus 3 into minus root 3. Okay, just adding those two and well, you'll get minus 7 root 7. Now, this is pretty simple too again. Might confuse a little bit of people, but it's really not that hard if you know your basic trig fundamentals. All you're doing is multiplying the both causes, right? So it's negative cos squared theta and minus sin squared theta, right? If you got lost, tell me, because it's cos theta into minus cos theta plus multiply the y components minus sin theta into sin theta, right? And then when you do multiply these two, it becomes minus cos squared theta minus sin squared theta. Here, take the minus out. So it's cos squared theta plus sin squared theta. And if you remember, this cos squared theta plus sin squared theta is actually equal to 1. That's a property. So it's going to be minus 1. Easy. Oh no, should I go with purple or... Yeah, I really don't know, because we could change it anytime in the end. No, I think this is good. Okay, nice. So, on page 2 now, the question's asking us to find the cosine of the angle between... Angle between vector u and vector v. So first, let's go on to sketch this diagram. I always like to, sketch vector diagrams because it makes me make more intuitive sense of the vector when I see where they are. See, this is 2, 3, right? So if we start from the origin and go to the coordinate of 2, 3, so 2, let's say there, and then 3 here, the vector is pointing from the origin in the direction of 2, 3. And this is vector u. And vector v, they're saying is minus 1, 4, somewhere like here. Nice. And this is vector v. Okay. And they just want, let's see the question. State which angle the quadrant angle lies in. Okay, they want us the cosine of the angle between both the vectors. So, if I read it right, and my judgment's right, they just want this theta in between both of them. So, how are we going to find this theta? Well, I don't want you to remember that we were focusing on dot products all this time. Okay, and we have two products. We have two vectors already. So, if you know the general form, when you multiply two vectors, right, what happens? When you multiply vector u times vector v, what do you think happens? Well, it's going to be the magnitude of vector u times the magnitude of vector v. Okay, that's what's happening, because you can't multiply two vectors, you're multiplying the magnitudes. This is the magnitude. You're multiplying the magnitudes of the vectors. You're not multiplying the coordinates of the vectors. Okay, so when you multiply this, that's for the normal vectors, right? If they're acting in like the same direction, in like one direction. But then when you see vectors acting in like, you know, angles to the horizontal, then we need to take into consideration of this cosine of like this angle. Okay, when you have vectors like this and the theta in the middle, we need to take into consideration of this theta. How do we do that? Think this is a right angle triangle and we want this. So this is just going to be this, which is our, let's say A over the hypotenuse. So it's just going to be cosine of theta. Okay, so the formula for vector u times vector v is the magnitude of vector u times the magnitude of vector v cosine of theta. Okay, simple. So now that we know that, we want theta, right? So theta is equal to cos inverse of vector u times vector v over, you're just shifting this over to the other side. You get what I mean? Take this, divide it through, so you get cos theta, and then theta is just cos inverse. So you can do it all in one step. U times v over the magnitude of vector u and the magnitude of vector v. Okay, easy. We know that this is what we want to find. Now, I want you to go in the side and I want you to draw this. So, what we're going to do is first we're going to do vector u times vector v. We're going to take the dot product, right? What's this dot product? Well, vector u times vector v is just, what's vector u again? 2, 3 into, yes, 1 minus 4. So that's just equal to 2 plus minus 12, which is just minus 10. Okay, what's the magnitude of vector u? So if you do not know the magnitude, basically it's just asking, see how this is vector v, right? Vector u. Let me just explain what the magnitude means. If this is at 2 and 1, 2, 3, somewhere like here, see how it kind of makes a right angle? And you can call this theta. See how this is 3 and this is 2. Magnitude is basically this length. Okay, and by basic Pythagoras, you know that this length is just equal to square root of 3 squared plus 2 squared. So anytime they ask you for magnitude, don't be afraid to just take the square root of both the numbers that they've given squared. This is strictly for 3U because we only have 2 vectors, but when we go to 3D vectors, that's another challenge. But I'm not going to go there because I don't want to go there. Yeah. So vector u is just equal to the square root of 3 squared plus 2 squared, which is equal to square root 13. And vector v's magnitude is equal to the square root of 1 squared plus minus 4 squared. Remember, the negative signs don't matter because you are square rooting them at the end of the day. So what's 4 squared is 16 plus 1 is 15. So we just have root. Wait, 4 squared is 16 plus 1 is 17. So you have root 17. Alrighty. So this is our basic information that we do need. The reason we have this on the side is so that we can come back to it. We'll be like, oh, when are we going to come back to it? Very soon. So let's label this box as a star. Okay, label this as a star, and let's get back to our actual calculations. Theta is here. We just got to sub in, right? What are we subbing in? Vector u dot v, so the dot product of u and v, which is minus 10, over magnitude of vector u times the magnitude of vector v. Root 13 times root 17. And then just say the markers from, you got this information all from the star, so they know where to look. And actually when you go on to calculate this, you'll get, oh wait, actually, yeah, this is cos inverse, right? But you actually didn't need to go this far because yeah, rookier, not really rookie. See how they asked cosine of the angle? They actually don't want theta, they want cos theta. So you can actually take cos inverse to the other side. So it's just going to be cos theta is equal to minus 10 over root 13 into root 17. And what's root 13 into root 17? Let's do that. That's just root 221. So it's minus 10 over square root of 221. And that's our final answer because they asked cosine theta. Nice. Let's go to a second question. So we'll do each levels and exercises in parts, and then I guess we'll take a break if required. Now they're asking us, find the cosine of the angle between these two and state which quadrant. Okay, state which quadrant this lies in. It lies in the second quadrant. So to figure out what quadrant it lies in, you did have to go on and take the cos inverse of theta, which happened to be 132 degrees for your information. But all that doesn't matter now because we're back at it again. So easy, a normal diagram. We notice that no numbers are negative here, so we can go and hey, what's happening? Okay, as we notice that none of the numbers are negative, we can construct our axis purely on the upper x-axis. So we got phi 1 something like this, vector u, and vector v is 2 3. Vector v. Okay, and state which quadrant, and the angle, yeah, of course they want this angle again, and it's the same process again, same job, same irritating job. See, cosine of theta is equal to u vector u dotted with vector v is equal to the magnitude of vector u, magnitude of vector v, cos theta. So cos theta is equal to u dot vector v over magnitude of u, magnitude of v, which is equal to, well, we're going to sub in the numbers, so let's go and do our starting here. Vector u times vector v is equal to, what's this equal to? Well, u dot v is just phi 1 multiplied by 2 3, and that's equal to 10 plus 3, which is 13. And then magnitude of vector u, well, that's just equal to the square root of 5 squared plus 1 squared, which is 25 plus 1, so square root of 26. And then vector v is just equal to the square root of 2 squared plus 3 squared, which is equal to 5. Oh no, my bad. Root 13. I got confused. And let this be another star. Okay? So then you go on here and you can sub it in. We know u dot v is 13. 13 over. What's v in here? Root 26 and root 13. And what's that simplified? Well, 13 will stay on the top over root 26 times root 13. It's gonna be root 2 on 2. Simple. That is our final answer. But don't forget what the question entirely asked you for. It also asked you for the quadrant. So for the quadrant, you're gonna be wanting to take cos inverse of root 2 on 2, and that happens to be 45 degrees. So you see, so theta is equal to 45 degrees, hence it's in easy. Okay, that's how you solve these types of questions. So looks like the other questions look the exact same to me. So let's just speed run it, okay? Let's see how fast we can do it. 2-1. So this looks about 2-1. So we're just, it's not going to be neat now anymore though. It's usually a good, rule of thumb. Okay, so it's a good rule of thumb to define the vectors. So let vector u is equal to 2 comma minus 1 and v is equal to 2 1. Okay, then draw your sketch. So 2 minus 1, that's vector u, and vector v is like vector v, so it's 2 1. Okay, and they want the theta here. They want the theta there. Simple. So all we need to do is, we know that our theta, find the acute angle. Oh, so they only have the angle. So now we can go full theta. Theta is equal to cos inverse of, first let's do our, dot product investigation. So u dot into v dot is equal to 2 minus 1 into 2 1. Which is 4 minus 1, which is 3. The magnitude of vector u and the magnitude of v. See, the magnitude of u is actually, they're actually both going to be equal to root 5, now that I think about it. And let's put that as a star. Also, anytime you take the information out, so from this step to this step, just say from star, because where did you get these numbers from? You actually got them from the star that you created. Easy. So cos for theta is just equal to, we just sub the numbers in. We remember that the top is the dot product of u into v, vector u into v, so that's 3. So it's just 3 over magnitude of vector u, magnitude of vector v, so root 5 into root 5. Okay, and when you evaluate this cosine of theta, you do get 53 degrees 8 minutes, but it asks to the nearest degree, so we can leave it at 58 degrees. Okay, nearest dig, if you want. And well, finally we have one more part. But look, seriously, I don't want to go through this. You guys should know how to do it. It's boring. But I'll do it. Okay, I'm so bored of doing this 4 times in a row. I'm not even gonna do the stars anymore. Bro, remember, theta is what they want. That's cos inverse of dot product this. What's 5 times minus 1? Minus 5 plus 6, which is 1. So you got dot product as 1 over, take square root of 5 squared plus 2 squared. That's root 29 into root minus 1. So 1 times, 1 plus 3 squared, which is root 10. Okay, so then cos inverse of this, 1 on root 29 times root 10 is equal to 86 degrees 38 minutes, which is to the nearest degree 87 degrees. Okay, so you can do it all in one step, and yeah, you didn't need to necessarily do all this working out. Nice. That's the end of level 1, the first 2 pages. Now